Welcome to the Structural Engineering Podcast.
We're your hosts, Zach and Max, structural engineers passionate about unraveling the complexities of our architectural wonders.
Whether you're a seasoned professional, an aspiring engineer, or simply fascinated by the science behind skyscrapers and bridges, you've come to the right place.
In each episode, we bring you insightful interviews with leading professionals.
So grab your hard hat,
or maybe your calculator,
sharpen your pencils, and get ready to explore the fascinating world of structural engineering. This is
the Structural Engineering Podcast.
On this week's episode, we talk with Marcio, the founder of Mola.
We learned so much about how these kits started, the development of them in an academic setting, and how they are frequently used in practicing engineering firms as well. We just heard that the newest Mola kit will be released on Kickstarter. We got to learn about the structural concepts being shown in this version.
We're really excited about the release of Mola 4. Check out the show notes for the link to the Kickstarter campaign. And make sure to listen to the end of the episode to learn more about some of the exciting features that will be added to Mola very soon. New ways to think about dynamics and structures and so much more. We really like it. Now let's start the episode.
My name is Marcio Sequeira. I am an architect from Brazil, and I've been dedicated the last 20 years to development of this structural model that we call Mola structural system to make it easier for people to understand structural behavior in a qualitative way. So this is basically what we do, and it's a long journey and a lot of things to discuss and to share with you.
Well, we're super excited to talk to you. So both of us have Mola kits and really love them. They've been awesome to help explain engineering concepts, and they're also just really fun to play with. Of course, I grew up building Legos, so this fits in very well to my life. I'm wondering if you could start by talking about how long you've been around and how the idea was created.
Okay, as I said, I'm an architect. So when I was a student, I kind of struggled with structural classes at the university because they're mainly taught through calculations. So I even like math and I was going good with the math stuff, but at the end, I could not apply this to the architecture activity. How can I use this information to design a building or to define a shape or anything? So I was really bothered about not knowing how structures behave. So the idea for Mola came for this personal need to understand the subject in a more intuitive and practical way. And before going through this, I'm just going to mention that I always was interested about structures. My father works with steel construction. So since I was a student, even before that, I was in contact with structures all the time because he built structures. So this was a subject that I was really interested about during graduation. But when I graduated, I realized I didn't understand about structures at all. And I decided to study more. And after graduation, I took 1 year course on steel construction for architects. It was a specific course for architects. And the idea from Mola came to me during this course, during the classes. And we are designing, we had a design class that we need to design a roof system for a specific project. And we thought about doing a trusted arch. And I wasn't comfortable about designing something that I didn't know how it works. So I decided to build an arch by myself. And I bought some wood sticks and magnets and start building this arch at home. We didn't have a structural lab at the university, so I started doing this at home just for my personal need to understand what we were designing. And the experience was really amazing because I could build that arch and understand the stability, how it works, just by playing with the pieces, just like you mentioned Lego. And it was so nice that I thought, okay, I understand how the arch behaves, but I start to ask myself what's happening on each bar of this structure. So I had the global behavior analysis, but I couldn't understand what's going on each element because the wood stick was really rigid and I couldn't see anything. So I thought, okay, I think I need another material. So I could understand what is that, there's compression and tension. Is there an element that I can take out of the structure and nothing's going to happen? Or which element is receiving more load or less load? How can I analyze this in a really simple way? So after that, I start testing different materials from plastic to rubber, barbecue wood sticks, everything that I got in front of me. I start using and trying to find this material that I could get big deformations. And after taking out the load, you go back to the original position and you allow me to build all the structures after that. And something really interesting happened because I spent the entire day working with the plastic tubes, and the plastic tubes were still too much rigid. I couldn't see too much. And then I went to take a shower, and I had an electric shower, and I need to change the resistance of the electric shower. And the resistance of electric shower, it's a spring. And when I took the spring out of the plastic bag and I was moving like this, and I was like, okay, maybe using spring
Perfectly, yeah.
could be a good solution for this. And I'm not saying this as something magical or special that happens to me. It's more like doing things over and over again, testing all types of materials until you are prepared to realize those things, realize the answers that are over there in other fields and other areas that you can take for you and solve your problem. So this was how I decided to use the springs and how things actually started. But it was after months of tests. And that's why we call Mola structural system, because Mola means spring in Portuguese. And the
Oh,
main
that makes much more
idea,
sense.
yeah, the main idea for the solution is using the spring as a bar element. So that's why we have Mola as a name. And this is how it started. And but at the beginning, we had only the bars and the connections, which were the spheres and the magnets that would make the connection. So it was all. I had only bars and connections, pinnet connections, right? So after that, I started designing this desire to see more. So I started designing all the other components to get closer to a real structure. How can we simulate so many different structural systems with this construction set? And well, this is a little bit how everything started. So as a student.
It's exciting to me to learn that you come from the architecture background because I was, just picturing this is a great way to talk about force transfer or something, but it's really how shape and structure interact is how I kind of viewed it in my head. So I'm glad that was really the root of this is the architecture. And my first degree is in architecture. I wasn't very good at it, so I jumped to engineering, but but I'm glad that there's actually a real mesh up here of those concepts.
Yeah, one thing that I still thinking, maybe because I'm from an architecture course and didn't have too much classes and understanding about structures, maybe I could see this from another angle. And maybe this the reason of finding something different that was out there. I don't know. And it's interesting because when I talk to engineers today, they all say we always use spring behavior to simulate and to analyze structures, and why we never thought about using springs in a physical model. And maybe it's another perspective of seeing the problem from another way. I don't know.
That makes so much sense too. And as you're walking through kind of your evolution of the pieces you're using, I mean, it's just so logical that you ended up at a spring. I mean, that's really cool. So continuing with the evolution, you kind of brought on of how you got there. What did the first Mola kit look like, and what has been the big developments so far on this journey?
Okay, as I mentioned, I had only the bars and the connections. It was already really nice to simulate some stuff, but I wanted to make something really versatile and that could represent a lot of structural systems. So everything that I was studying at this course. So the great challenge of this project is to make something really simple uh, with the less quantity of pieces possible, could not have like 100 of different pieces. It would be really complicated to use, expensive to make. So it needed to be really compact. And at the same time, it needs to be similar to real structural behavior. So it's a really challenge to meet all these characteristics for the model. And then after that, I start to trying to get to the most structural systems I could. So I realized, okay, I need a rigid connection. How can I make a rigid connection? And how can I simulate this? For example, every time I start with something really complex. And through the tests, I try to get to something really simpler and that could make it easy for everyone to use. So for the rigid connections, we start with different ways of connecting the springs to the sphere, some hole, something that could fix inside. And at the end, we come up with a really simple piece that comes from outside and connects the two bars in the connection at the same time. Looks like a triangle component. You just click to the structure and make it rigid, and you can take it out every time you want. So we always want a model that could be easy to adapt, so you can test different stuff. So after the bars and the peanut connections, I designed the rigid connections, and after that, we didn't have the connection for the column on the ground, for example, simulating like a foundation. So I started to design all these new components to get similar to a real structure. And at the beginning, we didn't have a product, we didn't have a brand or a company. I was designing this by my own. It had the system as a global thing. We didn't had so this is the pieces from Mola 1 or this is the pieces from Mola 2. We didn't have even the idea of creating different sets with numbers, and it was just the system. And when I start designing this model, it was during this course, one of the professors that saw Mola for the first time, he came to me and said, okay, I think you need to patent this now. And he said, this looks really good, and I think you should keep work on that. And then another professor invited me to take a master's degree in civil engineering in structures. So I accept the challenge with one condition, that my research was about the model. So I said, okay, I'll take the challenge to do a master in civil engineering, but I want to study this model that I'm designing. And he was like, okay,
exciting.
yeah, he was like, okay, this is what I was thinking. So my research was to prove that the behavior that we saw on the Mola system was really similar to a real structure. We knew it was similar based on class notes, books, things that I was studying, but we want to prove that for different structural systems, you can trust the model to make these simulations. And again, this is all qualitative, okay? So what we did is that we took a lot of different structural systems from single elements like columns, beams, plane frames, trusses, and more complex structures like space frames, space trusses, and other things. And we simulated the model, and we got a specific load case, and we took pictures of the deformed shape of the physical model. And at the same time, we did software analysis of a real structure with the same proportion, with the same load case. And the software generates the deformed shape for this structure. And we overlap the images to see if it was similar or not. And at the end, the model is more precise than we imagined.
Oh my gosh.
We have this research on Mola's website that you can download and check it out. It's really amazing, the results. This was really fascinating because it gives more stimulation to keep work on this. So this was part of this process of designing and how Mola came to be what it is today. So it was like almost 3 years, the master course that I took. It was all part of the development and validation and showing also the desire from making something reliable, something that people can trust to design a structure or simulate or to teach. And
My next question is really related to that, but it's hard because you're gonna be picking your favorite is my question here. So, what are the most interesting structural concepts that you've seen shown with Mola? So, like connections, base fixity, tension. Is there one that took the longest to develop, and once you got it, it's like it just felt perfect?
okay, there are few moments that I remember, like coming up with a solution that it really feels good. uh, but one thing that I think it's satisfying about the system is that how you can change the structure anytime you want. Not just a specific connection or a specific solution, but because most of the models, traditional models that we have, they're specific for a specific structural system. And usually you cannot change the boundary conditions and the characteristics for this structure. So you get always the same result. And what I think it's most interesting about Mola is that you can change the structure anytime you want. So if you build a simple plane frame, the variety of configurations you can add to this structure, it's really interesting to simulate all these possibilities just by clicking one component, taking out, applying the load, and see what happens. And I think this is the most interesting thing about Mola, how you can change and do the solution you are thinking and understand by experiments what's going to happen. And all the load application is made manually. So you bring another level of communication to the learning process, which you can feel the difference between a braced frame for a rigid frame, and it's so clear when you do it. And I think this is the most interesting thing about Mola. There's one component that we've designed in collaboration with other people, because we are always talking to a lot of people, professors. Sometimes with my father, he's always involved with discussions and stuff,
That's awesome.
which is the adjustable length bar. Based on what people were designing, we realized that having specific lengths for the bars, this was a limitation, right? To create different structures. So we designed a spring that you can twist one side and it gets bigger or smaller anytime you want. So this gives you a lot of possibilities. And this was a really, it felt so good to come up with this solution. And it still works as a spring. So still get deformed. You can see the deformed shape, and you also can change the length. So
That is
yeah,
very exciting to me because playing around with the Mola 2, I think that I have, I thought about like, well, it'd be really nice if this could just be a little shorter. So I'm extremely excited.
yes, and a lot of things that we do, it's also based on what people are doing and what they are trying to do with the system. And we are always trying to learn from users to get better, to make a better product.
Yeah, it's been pretty fun to have. I brought them into the office this summer. We had a few interns and they started making structures with it of and had ideas that I could never have thought about. And then Max had put together this little motor that had a little offset weight to oscillate to kind of shake the structures for an earthquake. And it was phenomenal that not only does the structure act how you'd imagine it to act, just by pushing on it, but you add this oscillating load to it, let's say an earthquake, and it still acts how you'd expect it to act. So it has been phenomenal to be able to build things with and show young engineers, how things work. And you're so right, like the communication you have with it, because you're pushing on it and you're building it, is phenomenal. And I think, really shows and teaches a lot differently than sitting in a classroom and looking, at a screen and just believing someone else that that's how the structure would act. So it's phenomenal.
Yeah, thank you. It's nice to hear that. And one thing that is nice to make it clear is that we are never talking against calculation or all the verification process that every structure needs to have, but we are just adding another level of analysis, which is totally qualitative, where you're gonna understand the behavior and get you more prepared to all the process that needs to be uh, filled for verifying and designing a structure. This is really important to mention, because sometimes people misunderstand that Mola is going to replace something, and that's not the idea. We're just adding a new layer of knowledge so people can be more prepared. And as you mentioned, some of dynamic behavior. Um, it's really interesting because as we amplify deformations with the springs, right? When you use the springs, we amplify deformations. And for dynamics, this is really good because you can actually see the frequency the structures moving, and you can understand like natural frequency based on the vibration, the amplitude, frequency, and everything. So a lot of concepts that you can easily understand just by seeing the structure move, either form, shake table, or other
Right.
element.
So what other stories have you received? I'm sure, as people have gotten their Mola kits, they've, come up with a lot of wild stories and stuff. What would you say is like, common things people reach out and say, now I understand this difficult concept, or, what is being learned?
Yeah, one thing that I've been doing some hands-on activities in a lot of universities worldwide, and they have Mola, and we do activities with the students. And it's really nice when we are working with students. Sometimes they are like already at the end of the course, civil engineering. And we hear this sometimes. They saying something, oh, so that's it. As they were doing this for so long, they're already studying this. And when they see it, and there's this moment of realizing what it actually represents, like visually, and this is really nice to hear and to see the students realizing this, and so many different concepts and different areas. um, and there are also different applications that we are seeing people doing, because the most interesting thing is that when you put Mola in the world so people can use, and people are creating different ways of using the product. And we are always learning um, from users, and especially in university. So a lot of professors creating different activities and applying the product in different stages, like graduation course, master degree courses, and civil engineering, architecture school. So many different applications that uh, it's really, really nice to see how people are taking care of the tool and creating different stuff.
Have you seen Mola used in professional workspace much? And like, do you have any stories from there?
Yes, there are some interesting cases. One is civil engineering office in Madrid, in Spain. They won a competition to design a pedestrian bridge connecting Portugal to Spain. It's like a 300 meters span of a suspension bridge, and they were designing this bridge. It's a suspension with the curved deck. It's not a common shape, and they had the desire to see and to feel this system at the early stages of the design process before going further and maybe realizing something way after doing a lot of analysis. So we collaborate on this project. They got in touch with us saying, okay, we want to see this, we want to touch it. And then we translated the design to the system, to the Mola system. When with all the components that we have in Mola 1, 2, and 3, we'll be able to design this structure, which is exactly the same system they were designing for the project. And we had a lot of meetings. This was during pandemic. So we had online meetings. We set the model. When we got to the final configuration, they said, okay, this is it. We packed everything. We create some instructions to assemble. We shipped to Spain. They receive it. They build on their design studio. And they said they took a lot of decisions in the design based on this qualitative analysis and at the early stages, like the construction process, stability, and other things that they could analyze based on the experience with the model, even though they have experience as engineers. So this was a really nice application. This is during the, now we are during the process to start building this bridge. So I hope this will be built and we have a case of something that was designed, actually used using Mola as a design tool, not as a educational tool. There are some cases that professionals, there's Angelina, now she's director of the NCSEA in the United States. And she once mentioned that she used Mola on a call, online call with a client to explain the solution she took for the design of his project. So it's another way of using Mola as a communication tool. So we're going to talk to someone that doesn't understand structures, so you can use as a communication tool. There's so many, but those two are really interesting. I have some academics applications as well, which was really nice. I will mention about, we talk about dynamics. So once we received an email from Professor Tal Cohen from MIT. This was a really special moment for me and for Mola. This was 2017. We received an email from her saying, okay, we have a really traditional way of teaching structures at MIT. We saw Mola in a university in Switzerland, and we want to use it here. And I was like, okay,
let's
do it. Yeah. And it ended up that she teaches structural dynamics at MIT. And this discipline, it's for all engineers at MIT, not only civil engineers. So all the different disciplines that needs to take dynamics takes this class. And the structural dynamics class at MIT, the final exam where the students are evaluated, they take a 1-month project that the task is design a structure with Mola structural system. And they need to, after designing the structure, they need to predict the behavior of this structure by calculation. And after that, they go to the lab, they put the structure on the shake table. They do the physical analysis, the experimental analysis with the model. And they, for example, they measure the displacements and the behavior of the structure through video recording. So they don't put sensors because it moves too much. They follow the pieces and they can measure through the video. And after that, they compare the results. So after they need to refine the calculations because it's not always the same exactly. So they need to refine and understand what's going different. And at the end, they need to create a mass damper system to that structure to minimize vibration based on the behavior they were analyzing. So, and one thing, they cannot use Mola components to make the mass damper. So they start to put like ketchup, yogurt, small cars, and rubber, and other materials to make it the pendulum systems and other stuff. So it's a really interesting project that Professor Cohen is designing this, and she's making every year. She's making improvements based on the experience that students have. But it's really interesting. It's about a month working with Mola, and at the end, every team needs to do a 10 minutes presentation at the end of the course explaining this whole process. And we are always invited to participate online. So we participate from Brazil on these presentations. And one thing that, just add another thing, Professor Cohen mentioned that not only the understanding of the structural behavior, dynamics, and all the technical stuff, she said one thing about Mola, which I think is really important in education, is that the subject dynamics, it's a really, let's say, cold subject. So usually students don't come to her to talk, to interact. It's a really cold discipline. And she said as soon as she put the kids in the class, it changed the atmosphere. The students were more involved. They were interested. They were getting in touch with her. And she said this is one of the most important things about adapting Mola to this class. So it's another thing, as I said, it's another communication channel that you create, and which is really, really important.
And that is what I was just thinking about too. Is I wish I had this in my dynamics class because it really like puts a physical component to your calculations. It's a different interaction with the math, and it just sounds wonderful.
Yeah.
There is a university in the UK at Surrey University, and Professor Alireza Benhajad, he created a project where students build real structures with steel bars and screws. The students need to build their structures, like real size structures, like big things. And during pandemic, that first, before assembling these structures, the students need to design the structure that they will assemble with these steel bars. And during pandemic, students couldn't be together to design the structures they will assemble after that. So they got in touch with us, and we shipped the kits to this university in UK. They received the kits and they shipped one kit to each student so they could talk online but have something like hands-on experience so they can discuss what will be the solution for their design using Mola. So this was another really interesting application during a difficult time where students couldn't get out of home, and so they could design this, have a online shot with something physical hands-on. So after that, when they were allowed to be on the campus, they assembled the structure, the real thing. So this was a really nice application. There's different from normal use of the model that's come up with another professor thinking differently.
Wow. These are amazing applications. One thing I was kind of curious about, and we don't need to maybe spend too much time, was on the manufacturing of Mola. As an engineer, the manufacturing process is so fascinating. So if you wouldn't mind just talking a little bit about, the design process, the materials used, and the challenges maybe faced with, developing a manufacturing process and all of that would be, I think, interesting to hear.
Okay, this is a big thing about Mola, is that because we care too much about the details, about the quality, about the materials, how we're going to present, how the information's in the book manual, how we pack the kit in a nice box to feel like a book, and everything is connected. And I've been learning a lot about materials, about production. I didn't have any experience about industrial design before, so I just learning through the process. And sometimes takes a lot of time to set the right material and the right way to produce it. Not only the right material, but how can you produce these components in big quantities? Um, what will be the best process for that? And to define which will be every material for each element. Not only the behavior, of course, the behavior of the structure that rules everything, but after that, how can we make it look good, feel good, connect easy, and how this could be easy to use. So it's a long process. Also finding suppliers, the right supplier for the components. This is all a big work that we do to set everything. Um, we had some great experience based on the quality of the product because when we launched Mola 2, um, we had wired writing about Mola, talking about the design, not about structures, but about the design of the product. And maybe in civil engineering, there's a lack on good design, I think, in material, like educational material, I mean. So when you have something that is really crafted with care, I think this is really important. Um, we have a really amazing, unexpected experience. Is because Apple has always been a reference for me when designing products. You can guess, look in Mola boxes, and there's some references. And I always liked the way they present the products, the simplicity, quality, presentation, and different aspects. And we realized there's one person went to our website and bought it Mola like 4 times in a row, like in sequence. And I was like, everybody was, okay, this guy bought so many times. Who's this person? And then we started looking and we saw his email was at apple.com. I'm like,
Oh,
okay,
cool.
the guy works at Apple. And it ended up, I looked for his name, and he's the industrial designer who has more patents at Apple history.
Oh my gosh.
And he was on the seniors designers. And I was like, I can't believe this. And then
That's
on
some
his
very
last
serious
order,
validation of like what you're
yes,
producing.
exactly. So I always say to our team, see, we are in the right direction. Let's keep looking for the details, for the quality and everything. And then on the last order, I wrote a letter explaining this and put in the box and shipped the products to him. On the next day, he received the products. On the next day, he sent an email inviting me to visit Apple Park and to visit the Apple Design Studio.
What?
And I spent 2 hours inside
Oh,
Apple talking about designing, prototyping, and all those things. And I realized they are using Mola at their design studios to teach intuition to the engineers. And they are not related to architecture or civil engineering or structures, but they're using
yeah.
the model to teach intuition. And this is one story that I never thought this could happen. And this is talking, when you talk about quality, about materials and everything, this is a validation that I don't know if there's a better one to have.
Yeah, it's
Yeah,
pure problem solving, like everything else aside.
exactly.
That's so exciting.
Yeah, now hearing your whole story too, everything makes so much sense, Max, knowing your background in architecture, I mean, the kits are beautiful. They're so nice. And I was just thinking, like, I wonder what it would have looked like if an engineer put it together. And I'm thinking just plastic little baggies that you
Black
get
white
in a,
box, yeah.
maybe a box, maybe not, maybe just an envelope you get it shipped to you. But that there's so much appeal to the Mola structural kits with how they look and they feel, and I mean that is really cool.
Thank you. Yeah, we use a lot of energy to keep things that way.
Yeah, it's exciting. So this conversation kind of started that we heard that you had a new Mola kit coming out very soon, and we've organized our questions to try to almost hide that till now because we didn't want to spill the beans, I suppose. Can you tell us about the new kit coming out? What's being added to this one? The name of this, just the full details.
Okay, so the idea for Mola kits is that every kit will have a specific component that allows you to build the specific structures. So as we have Mola 1, 2, and 3, and now we are launching Mola 4. So even the kits have specific structures. They are kind of connected about the subjects we talk on each set. So we start with Mola 1 with basic stuff like columns, beams, frames, trusses. In Mola 2, you get to continuum beams, grid systems, and a little bit more complex structures. Mola 3, we talk about cables. And we end Mola 3 book manual with form finding process, which is the relationship between cable behavior and the arch behavior. And so Mola 4, it's about arches and shell structures. So it's also connected to the whole system. So that's what we are talking on Mola 4. And Mola 4 it also has a new thing that we are adding a new material to the system, which was not obvious at the beginning, is that to simulate arches, we're gonna add the curved springs. This was okay. It's part of the one of the components, but in a different shape. So you can understand arches behavior. But to simulate shell structures, we are adding origami to the system. Origami and folding techniques. So to explain how the shape, the form, is important to the structure efficiency and how you can get efficiency through making folds and changing the shape of a material that's really flexible. It's a piece of paper, and how you can make this a stable structure, and to teach how this really thin shell structure stands based on that concept. So we design different connections to connect the surface to the system, and Mola 4 will allow people to customize their structures in a way that we didn't have before. Because in this connection that you're going to connect the surfaces, the paper, for example, you can go up to 1.5 millimeters thick material. So you can add cardboard or acrylic or any other material you can add to the system. Even 3D print a specific structural element, connect to this component which has the magnet, and you're ready to add this element to your structure. So this also will give a different level of customization for people's creation. So we are really excited about it. One thing that I didn't mention before, it's everything from Mola 1 until now, we funded through crowdfunding. So as long story short, I started designing Mola 2004, sorry. I launched Mola 1 2014, 10 years of design development, because I couldn't find investors to make this happen. And it took me 10 years to fund the first kit. And I only funded because I launched a crowdfunding campaign. And this is how I started the company. So I didn't have the company yet. I had an idea, I had the prototypes, but I couldn't find investors. And so I launched Mola 1 on crowdfunding, and I funded the company. And Mola 2, we did crowdfund again. Mola 3, and now we are going to Mola 4 again on a crowdfunding campaign on Kickstarter after 10 years from the first one. So this is part of the story about Mola.
Yeah.
Well, yeah, I think we're Max and I are out of questions. What else do you think we should discuss or bring up, or what else would you like to share before we close out the episode?
I think there's so many things we are designing for Mola, and we have so many things to do that maybe we can share a little bit what's coming after Mola 4.
Yes, please.
One thing nice to mention is that Mola 4 is coming live tomorrow. But actually, I don't know when this is going live. So
we're editing this as fast as we can, so it might have gone live today or maybe yesterday.
Mola 4 will be live on Kickstarter this September. And besides that, we are designing based on what people are doing and what they're requesting to use. We are designing so many accessories and things that you can use with your Mola kits. For example, we are designing a new shake table, a Mola specific shake table. We are designing a mass dumper kit with pendulum system and liquid tank systems, and so many things that we can add, and always trying to simulate as many structural systems as possible. So there's so many excited things like sensor kits and other things that we have on the new products to come. So we are really excited about everything. Mola, it's a Brazilian company. We're still a small team. We are a team of 9, but Mola is already in 103 countries worldwide, and this is amazing for us. And we have never been more excited about the new things that we are designing and how people are using. So yeah, we are coming with new stuff soon.
Oh my gosh, this is so exciting. This is like now that it's in my head and like I'm excited about it. I want to go design something.
Awesome. Well, thank you so much for joining us on this episode of the Structural Engineering Podcast. I think our listeners are really going to enjoy listening to this episode, and we're really excited for the Mola 4 campaign to start.
Great. Thank you so much for this experience. It was my pleasure to share a little bit about what we are doing and what's coming